Hey guys, this is Srini and you're watching the basics of Python tutorials on Python for Microscopists channel on YouTube. And these lectures, these tutorials are intended for beginning programmers, again, whether you're a student or researcher or someone who is interested in just automating image processing tasks. So in today's tutorial, let's actually start talking about lists and tuples and dictionaries. And this is a bit, now we started to get into a bit closer towards image processing. Lists are, so far we looked at integers, the floating point numbers, strings, and so on. And list is, as the name suggests, it's just a list of numbers or integers, strings, floating point numbers, and everything else. And images are nothing but a bunch of numbers. Yeah, it's a two-dimensional numbers. Let's say if it's a two-dimensional image. So this is very important to understand what lists are. So let's actually jump in and start understanding what these actually mean. So let me fire up the Spider interface. Again, this is the IDE we are using for our Python. And the reason why we are using Spider, which is part of our Anaconda distribution, is because it comes with a lot of libraries prepackaged, so we don't have to worry about installing all of these individually. So list, what is a list? A list is a bunch of numbers. For example, when you do assign variable a equals to 3, and when you type a, what type is a? A is an integer. Yeah, so this is an integer, and when you do a equals 3 point, and then when you do type a, this is a float. Okay, similarly you can assign a equals to, let's say 1 2 3 4 5. Okay, now this is a list, as you can see. Right up here, I don't even have to type the type of the data type. Let's go ahead and do that. The data type of a is, it is a list. And what is the size? It's the size of 5. And you can actually index, for example, if I type a2 here, so it returns a value of 3. This is nothing but what is at the second position. So remember, it always starts with 0. So a0 is 1, a1 is 2, a2 is 3. Okay, so let's do this one more time. A of 0 equals to 1. So this is the first entry in the list. And it actually goes to -1 also. I don't want to confuse you. You can work on this later, but a minus 1 is 5, which means if I go full circle from the other side, what is the first number? So in this case, it's 5. Okay, so you can actually extract individual elements of a list and you can assign it to something. So I can actually start a separate list saying that b equals to and then you can assign something. B equals to, let's say, a of 1. Okay, so now my b is an integer, which has a value of 2. Okay, so again, a list, you can have, again, you can have a two-dimensional list, which we'll talk about later on. Now, a list, you can change the list. For example, I have a equals 1 2 3 4 5. What if I want to add or replace something? So for example, let's say a of 2 equal to, let's just do something. Okay, what I just did is I replaced the third value, which is again 0 1 2, right? So I replaced number 3 here with a text, with a string that says something. So if I actually type a, if you look at the list here, if you look at the updated list a, it says 1 2 something 4 and 5. So a list doesn't necessarily have to have all the elements of the same type, like all elements having text. Here you can see it can be a mixture of text and integers and float, and it can be a mixture of anything. Now you can, there are a few operations. For example, you can actually take one of the numbers, let's say b equals to, and this can be a dot, What do we want to do? Let's pop. What does that mean? So when I type B, it should be equal to 5. So when you say pop, that actually removes the last entry in the list, and that's pretty much it. It removes it, and now we assigned it to another variable called B. Okay, and there are various operations like this. Again, you can go and search for these operations, but the whole point here is lists can be a one dimension, two dimensions, or n dimensional entries, and these entries can be numbers, they can be it can also be text. Now list can be modified, so we just change number 3 to text called something, and you can actually append it. So if you do a.append, let's go ahead and do this. A.append, I believe, again, this is curly brackets, and let's say this is new, and now when you type A, you can see 1, 2, something, 4, and this is new. And by the way, there is no 5 here because when we popped, it removes the last entry from the list. So it actually removed 5 from here. Let's try that again, okay? Let's just say a.pop, and when I type, well, it returned the value, this is new, but when I type A, this is new, the new entry is gone. Okay, so a.pop is nothing but it takes the last entry, removes it, and returns it. And you can assign that as another variable if you want. A bunch of other things that we can do. You can generate a list by typing, let's say a equals to, let's generate a list with a range of, let's say 10. So what does this do? I mean, you can see it right up here. It actually generated a list that has values from 0 to 9. Again, these are 10 numbers, always starts with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our list. So our list right now is nothing but 0, 1, 2, 3, 4, all the way through 9. And you can actually slice the list. Like, let's say if I print A and I want to go from 2 to 4, let's say it's going to just say 2 and 3, not including 4. Okay, so in this case 0, 1, 2. So 2 here means the number 2 here. Okay, and then it goes to 3, which is 3 here, and it's not including the 4. So it can be a bit confusing. It's including 2, but it's not including 4, right? The second one, it's not included. It's actually excluded. If I type print A, and let's do 2. Okay, now it is actually going from 2 until the end of the list. If you print 2 and a colon, I'm not giving the end point, so it's actually printing all the way from 2 and later. And exactly opposite is also true. If I type print A and colon 2, it's going to print 0 and 1. Okay, everything up to 2 and not including 2. And you can actually substitute or assign new values to this. So instead of print A to 4, let's just say A to 4 equals to, and let's replace those values with something else, 21, 22, for example. And if you print A, then we replaced 2 and 3 with 21 and 22. So again, a list is a bunch of numbers, text, anything, that's combined, and you can change a list, meaning you can insert, you can replace, you can pop, you can basically perform all types of operations, replace like a set of numbers, a subset of numbers within the list. So this is I mean, let's move on from lists to tuples right now. We'll come back to lists in a minute. And tuples, it's called T-U-P-L-E-S. Yeah, a tuple is like a list. It's exactly like a list, except if you look at the documentation of tuple, they say it's immutable. What does immutable mean? Immutable means you cannot change it. You cannot change a tuple. So for example, if I do, how do you define a tuple? It's exactly like a list. Let's say b equals to, and instead of square brackets, for a list, you use square brackets. So instead of square brackets, I'm going to use the regular bracket. I don't know what do we call this, but anyway, it doesn't parenthesis, I believe. So anyway, so let's define a tuple that is exactly the same, 3, 4, 5, and that's it. Now here you can see A is a list, B is a tuple of size 5. And tuples, just like list, you can actually have a tuple that's numbers, that's text. So for example, if I do C equals to, let's say, let's do some text, 1 and 2 and 3, this is another tuple. Okay, so this is also a tuple. Now you can actually do math. For example, I can do D equals B plus C, and now my D is nothing but B concatenated with C. So I take B, and at the end of B I'm actually adding C. So this is, and pretty much the same even for lists. When you add lists, let's see if we can add D equals to A plus B, because A is list, B is a tuple, A plus B. So it's going to come back and say, okay, you cannot concatenate a list and a tuple. Okay, but as you can see, you can add two tuples, but then we are not changing the tuple itself. When we are adding, we are creating a new tuple right now. So you can always do that. You can copy an existing one, you can add, you can subtract, and all of that, but you cannot modify an existing tuple, unlike what we have done with the list. With the list, we replaced certain values, we deleted certain values, but with a tuple, you cannot do that. Now, also, one other thing that you can do to find the length of a tuple. For example, let's do len of A. A is a list that actually tells us exactly the size of a list or a tuple. So if I do len B, it's going to say the size is 8 because it's 5 plus 3. We added B and C. So len and a couple other commands you can do. For example, let's go back to list A. You can actually do max. I believe this works. Max A. It gives you the maximum number within that specific list. Same thing with min, for example. You can also do min. And the same operations also work for tuples. And what else? You can convert a tuple into a list or a list into a tuple. So for example, we can just say, I've used A, B, C, D. Let's just go ahead and say E equals to tuple of A. So now E is nothing but exactly A, except I converted that list into a tuple. Exact opposite also works. You can actually take F equals to, I believe, list of, let's take one of the tuples, B. Yeah. So, and now F is a list. Okay. So you can convert between, lists and tuples. Now, in addition to these, actually, let me finish this off, this tutorial off by talking about something called dictionaries. A dictionary is also it's a list, except it has a key and a value. What do I mean by that? Let's define a dictionary called fruit, and a dictionary is defined by these curly brackets. Okay, and let's define banana, and then I put a colon. So banana is the key now. What is the value? Let's give the value to be a color like yellow. Okay, so you can see why these are called dictionaries, right? I mean, banana, I'm associating that with yellow. Now let's just say apple, and this would be, let's call this red, and let's do red, and let's do one more. I'm running out of fruits here. I don't know, let's call pear, P-E-A-R, pear, and this would be, I don't know, usually green. Let's call this green, and let's close it. So this is the dictionary, and you can see the type right here. It says it's a dictionary, and the size is 3, and we have a key and a value. Now, why do we need dictionaries? Now we can actually look at, for example, if you want to print something out here, if you want to print, let's just do fruit, and which fruit? Let's just call it apple, and then it's going to print red. So you can access the value by using the key, or you can access key by using a value. So this is these are dictionaries, and dictionaries can be modified just like lists. So for example, if we say what happens if we say I'm thinking what fruit to add actually, and let's just say fruit, and what do we say, grape equals to, I think this is how we add, equals to, well, we already, let's use a black grape. Okay, now when I said fruit, grape equals to black, you can see it added this to our dictionary. So now we have banana, apple, pear, and grape. So I can print it again here. I can just do fruit. You can see that this is our new dictionary right there. So dictionaries can be modified. You can add, you can delete. So let me just go ahead and say delete, D-E-L, F-R-U-I-T, and I believe it's again these apple, and apple is gone from our dictionary right here. So again, dictionaries are kind of like lists, except you have a key and a value for dictionary. Tuples again are like lists, except you cannot modify a tuple. They call it immutable. So let's go back to, let's finish this by going back to lists, because again, this is exactly what we'll be using for our image processing. Let me go ahead and define, do we still have our list? Yeah, we have our list A. Let's check. 0, 1, 21, 22, or something. Now, what if I want to do some math? So obviously, when you are working with images, it's a two-dimensional, let's say, list, two-dimensional array. By the way, you can define two-dimensional list just by typing. Let's see, B equals, let's say 2, 3, 2, 3, and 3, 4. So this is our two-dimensional list. Yeah, when you look at B, this is our two-dimensional list. This is all equivalent to writing a matrix of 2, 3, and then 3, 4 underneath. You can have n-dimensional, you can have multi-dimensional, 2, 3, 4, 5, you know, and then you can have any number of these. So typically an image is two-dimensional. Let's say it's a two-dimensional array. If you have a color image, then it is think of it as a three-dimensional. You have 2 dimensions plus the third dimension is the color, red, green, and blue. Let's say we want to do some sort of a math. Let's say we want to enhance red and decrease the amount of blue. So we want to multiply red by a positive, let's say more than 1, you know, higher than 1 value. And then we want to multiply blue by, let's say 0.1 or something, you know, to kind of play with the colors in an image. How do you do that? So let's take our list A here. Let's say this is a one-dimensional image. And what happens when I multiply this by 2? We would think that the brightness goes up by 2 times, right? I mean, we're multiplying each value by 2 times. But then if you multiply this by 2, it's actually taking the same list and putting it again. So it's concatenating the list. That's pretty much it. If I do A multiplied by 3, then it's going to, I mean, this is basically, it's displaying the same thing, except you have it 3 times right here. If I do A to the power of 2, then it should give me an error saying that you can't do that. Okay, but how do we do this? How do we do math to the lists? And that's exactly where the term numpy library actually comes into picture. So in our next lecture, let's look at numpy arrays and see how we can do some math with these lists or arrays in one-dimensional, two-dimensional, it doesn't matter. So I hope you found this very useful, and please practice lists. What I'm showing here are a few operations, you know, additions, subtractions, multiplications of of these lists, but there is a lot more, you know. Typing len gives you the length of this list. So what you can do is, if you have a list, a long list, and if you want to go through each element in the list, for example, then you can use len command to find out what is the length, and you can iterate, loop over, which we'll talk about later on, through each element in the list. So some of these are very useful, and again, you learn as you need it. You learn when you're typing. Do not be ashamed, I should say, of searching on Google, learning as much as you can by copying things that other people have done on GitHub or other locations. That is the best way to learn how to code. You cannot just, it's almost like talking to learn something. When you're learning Spanish, if you talk on a regular basis, you'll learn more. It's pretty much the same thing. If you code a lot, and especially if you cannot, code every day, just go through what others have written and try to digest. And that gives you an idea of various scenarios. Otherwise, just by yourself, sitting down, I'm pretty sure you won't be able to think of various scenarios. This is exactly how I learned, and hopefully this is how you can easily learn. So anyway, let's continue with numpy arrays in our next lecture, and I hope you found this lecture very useful. Thank you very much.